All right, let's just jump right into this explainer on Google's Gemma 4. If you've been following the rapid evolution of open weight models, you know that running genuinely capable AI on your own hardware has always been the holy grail. Well, with Gemma 4, we are finally crossing that threshold. We are moving away from experimental toys straight into production-ready local agents. We've got a great roadmap for you today, taking us from meeting the new Gemma 4 family and their built-in agentic features, all the way down to the gritty realities of local hardware, troubleshooting your setup, and finally weighing local versus cloud AI. Let's get started. First up, the new open weight champions. Let's meet the Gemma 4 family. Now, look at the 26B model, for example. It uses a mixture of experts, or MOE architecture, meaning you get near flagship reasoning, but it's only activating 3.8 billion parameters per token. That is incredibly efficient. Plus, it rocks a massive 256K context window. But, don't sleep on the tiny E2B model either. It literally squeezes into less than 1.5 gigs of RAM. We're talking Raspberry Pi or smartphone territory here, totally offline. And then there's the flagship, the 31B dense model, which is ranking third globally among all open models right now. But it's not just about the raw specs. This is absolutely crucial. Gemma 4 is fully Apache 2.0 licensed. That means zero commercial restrictions for you, no weird monthly active user caps, no hidden enterprise gotchas. You have the full right to build, redistribute, and monetize your own products using these models. It's a massive shift that sets a totally new standard for OpenAI. Moving on to why Gemma 4 is being hailed as truly agentic right out of the box. So the coolest part here is a feature called extended thinking. When you enable this, just by passing enable_thinking equals true in your inference call, the model doesn't just spit out an answer. It actually generates a visible chain of thought reasoning trace first. You literally get to see how your agent is planning and making decisions. If you've ever tried debugging an agent that's gone completely off the rails, you know this is an absolute lifesaver. And it gets better. Gemma 4 handles native function calling and even computer vision bounding boxes directly. No more messy prompt engineering workarounds just to trick an open model into giving you valid JSON. It natively understands tool schemas. It can even look at a screenshot, figure out the exact coordinates for a UI click, and fire off an API call based on what it sees, all in one single pass. It is literally trained from the ground up to act as an agent. So how are they doing this? Let's dive into the science of small models and see how they punch so far above their weight.
It's not magic, it's just incredibly clever engineering. Google DeepMind essentially took the foundational research from Gemma 2 and pushed it even further to get this massive performance out of really practical, smaller-sized models.
One of the biggest secrets here is knowledge distillation. Normally, training from scratch means you're just teaching a model to predict the next token, and your performance gains stall out logarithmically. But with distillation, it's like having a brilliant professor mentor a student. The smaller model learns directly from the rich probability distributions of a massive teacher model, so it's getting way higher quality information at every single training step. They also layered in some pretty deep architectural tweaks. For instance, they interleave a local sliding window of 4096 tokens with global attention. This totally optimizes how the context is processed. Add in grouped query attention for speed and logit soft capping to keep the math stable during training, and, well, these hyper-optimized choices are exactly why a tiny 2.3 billion parameter model can now pull off tasks that used to require a massive cloud server. All right, let's get into the gritty reality of actually running Gemma 4 locally on your own hardware using Ollama. Because let's be real, the specs on paper don't always match the reality on your desk. Take a look at this. You might see the 26B MoE model and think, awesome, only 3.8 billion active parameters. I'll definitely run that. But hold on, the total model size is still over 25 billion parameters. When you load that up, it eats about 17 gigabytes of VRAM. If you're on a 24 gig Mac Mini, that leaves practically nothing for your OS. It's going to swap heavily and your system will probably freeze. For your everyday coding and agent tasks, you're honestly way better off with the default 8B model. It uses about 9.6 gigs and gives you a super smooth experience. Now, if you want the absolute best performance using Ollama, especially on a Mac, you've got to follow these specific steps. First, install Ollama via Homebrew. That automatically hooks into Apple's MLX framework for way faster inference. Second, out of the box, Ollama unloads models after 5 minutes of downtime. Super annoying if you step away for coffee, right?
Just set your Ollama underscore keep alive environment variable to -1. That keeps the model persistently loaded and warm in memory. Because, as one developer put it perfectly, pushing your VRAM to the absolute limit with that 26B model can literally ruin your day. Screen freezing, chat timeouts, no bueno. Always remember to leave enough headroom for your operating system processes. Of course, bleeding-edge tech never works perfectly on the first try. So let's talk troubleshooting and fix the most common setup headaches builders are running into right now. If you've been slamming your keyboard trying to run a llama poll and getting a requires newer version error, or just watching the progress bar crawl at a snail's pace, you're definitely not alone. The community forums are completely flooded with these two specific issues. First up, the version error. Gemma 4 absolutely requires a llama version 0.20.5 or higher. It sounds obvious, but if you don't realize your version is outdated, you can spend hours wondering why your terminal is throwing errors. Just run the official install script again to force the upgrade, and you'll be good to go. Now, the slow download issue is a sneaky little networking trap. When you pull the model, the initial request hits the Ollama registry. But then it hits the 307 redirect to Cloudflare R2 storage for the actual massive file download. If you're running a custom DNS, a proxy, or split routing, and you only whitelisted the Ollama domain, your multi-gigabyte download will time out and throw an unexpected EOF error. Just adjust your network rules to include that Cloudflare R2 domain, and your download speeds will go right back to normal. Finally, let's weigh our options, local versus cloud AI. Because as amazing as having a local agent is, it's not always the perfect tool for every single job. The reality is you probably want a hybrid approach. If you've got high-volume tasks or you're dealing with sensitive healthcare or financial data that simply cannot leave your machine, Gemma 4 is a total godsend. Zero API costs, absolute privacy. But if you're tackling incredibly complex, open-ended multi-agent coordination or edge case reasoning, the massive cloud APIs definitely still have their place. We're really seeing the industry settle into about a 70-30 split. Local open models doing the heavy daily lifting, and closed cloud models handling the extreme edge cases. The open source capability gap has essentially closed. You now have a fully agentic Apache 2.0 licensed AI sitting right on your laptop. It understands tools, reads images, maps out its reasoning, and costs absolutely nothing to run. The era of hacking prompts together is fading fast. Native agentic workflows are here. So the only question left is, what are you going to build today? Get your environment set up, pull those models, and let's find out.